Hello, Radioverse AI viewers. We've all had an X-ray taken, but have you ever stopped to wonder how these invisible waves of energy are actually created? X-rays are everywhere, from natural sources like the sun to man-made sources like our phones. Today, we're diving deep into the heart of the X-ray tube to discover the components and incredible physics that makes them possible. As viewed in the image, the key components that make up the X-ray tube includes cathode, anode, window, lead casing, etc. Electrons are expected to be emitted from the filament of the cathode to the anode. To get the electrons to move from the negative cathode to the positive anode, we need a massive electrical push, a very high voltage, sometimes up to 120 kilovolts. This high voltage creates a huge potential difference, accelerating the emitted electrons to incredible speeds, about half the speed of light. They become a high-energy beam. The kinetic energy of this electron beam determines the energy, and thus the penetrating power, of the X-rays that will be produced. Now for the crucial moment, when this high-speed electron beam violently slams into the metal anode target, their massive kinetic energy is instantly converted into two things: heat and X-rays. The first, and most common, way X-rays are produced is called Bremsstrahlung, or braking radiation. As an electron passes close to the nucleus of a target atom, the powerful positive charge of the nucleus slows the electron down, causing it to lose energy, which is emitted as an X-ray photon. The second method produces characteristic X-rays. This happens when an incoming electron knocks out an electron from an inner electron shell of a target atom. An electron from a higher energy outer shell then drops down to fill that empty space, releasing the energy difference as a mono-energetic X-ray photon. Here is the biggest hurdle: over 99% of the energy from the electron impact is converted into useless heat. Only about 1% becomes X-rays. To prevent the anode from melting, X-ray tubes use clever engineering, like a rotating anode to spread the heat, and often a cooling oil bath to dissipate the energy. The resulting photons pass through soft tissues, but are absorbed by dense materials like bone, creating the classic image we recognize. And there you have it, the high-energy journey of an electron, culminating in the powerful, invisible wave we call the X-ray. If you found this video informative, please like, subscribe, and hit that notification bell for more deep dives into science and technology. Thanks for watching Radioverse AI.